The Log4j vulnerability, like the OpenSSL Heartbleed or Apache Struts vulnerabilities that came before it, have been a wake-up call to our industry to understand that it's not just enough to respond to a vulnerability by redeploying applications once a patch is available. You've also got to be able to explore and discover instances of that vulnerability in your production platform. Deepfence ThreatMapper does exactly that. It scans production platforms, multiple types, clouds, application modalities, matching what it discovers against lists of vulnerability feeds, and then presents and ranks the discovered vulnerabilities based on their risk of exploit, their proximity to the attack surface that your application poses. And alongside Deepfence ThreatMapper comes ThreatStryker, an extension that adapts itself specifically to the behavior of attackers within your application, capturing network traffic and identifying when attacks are in flow and stopping them immediately. Let's begin by looking at the topology. It's like a scan for your entire cloud across multiple clouds, regions, cloud native modalities, Kubernetes, the lot. Here we've kept things really simple. We're running in DigitalOcean, we have a single virtual machine, and we're running a bunch of containers on this virtual machine. One of them is the Log4j vulnerable application. There are other containers running as well. There's an HA proxy behind which the Log4j application is sitting. This is all in runtime, so every couple of seconds we grab the connection data and render it. It's vital to have this runtime context so you understand what the vulnerability is facing, what is the real risk of it being exploited. So let's click on this container. Let's see what ThreatMapper has discovered about it. You see, there's a bunch of vulnerabilities we've uncovered, 82 of them to be specific, and 2 of these are marked as critical. We'll take a little look at those in a minute, but let's understand how ThreatMapper goes about scanning images. We can scan individual containers, we can scan the base operating system, we can look at just general packages, vulnerabilities, or we can delve down and run specific tests for particular languages and language packages. And we put all of this information together to give you an accurate, at this time, list of the potential vulnerabilities that your application may be subject to. This scan completed a couple of days ago, so let's go ahead and see the vulnerabilities and how they're displayed. There are 2 ways they're displayed. The first is a table or report giving you the most exploitable vulnerabilities. And here we have, right at the top, 44228, the most serious vulnerability on this node. There are a bunch of other vulnerabilities reported from adjacent nodes. There's a vulnerable WordPress instance running here. Let's look at the most interesting feature, the one that is strongest in helping you understand how vulnerabilities can be exploited, and that's the attack path. One of the things that ThreatMapper does is it matches the vulnerability to routes by which external network traffic could reach that component. This tells you how an attacker might mount a reconnaissance attempt, find ways through your ingress controllers and load balancers, and start finding vulnerabilities in your application running behind those edge network devices. Starting from the attack path, we can see these routes precisely. We can see the containers, the ports that they're accepting traffic on, and the CVEs that they may be vulnerable to. This is super important. It helps you prioritize some vulnerabilities over others based on their risk of exploit. With ThreatMapper, of course, you can dig deeper from here. You get all the details that you want. The offending package, where it resides, i.e. the container it's running in, the CVSS scores, and other data that helps you understand what's behind this vulnerability and how should you respond. So for example, here you can see that this particular vulnerability has got information about the resolution, the CVE or the release in which it was fixed. Of course, in this situation, things are super fluid. We're running this test as more and more vulnerabilities are being discovered in Log4j. And that's why ThreatMapper pulls in multiple different threat feeds and gives you the most up-to-date one for a particular vulnerability. Where possible, we also include links to external resources, other places you could go to get late-breaking information about the vulnerability. And so in summary, ThreatMapper is an open source platform that learns the topology of your applications, identifies potentially vulnerable workloads and scans those against over 50 different threat feeds, and gives you real-time, accurate information about the vulnerabilities that each of those workloads may exhibit. ThreatMapper then correlates that with the attack surface, telling you which vulnerabilities are at the greatest risk of exploit so that you know what to fix first. ThreatStryker takes things one step further and gives you the insight that's specific to your application. What are attackers doing to try and find vulnerabilities? Have they found an initial exploit? Are they using that to spread laterally and gain additional control within your application? ThreatStryker picks up where ThreatMapper finishes. We look at the topology, we identify nodes, and then we can say, you know what, let's perform some deep packet inspection of the traffic for a particular node. ThreatStryker will do this automatically, but let's just do it manually by way of demonstration. We can pick a node, an entire virtual machine or a container. We can identify the individual processes that we wish to instrument. And then we can track and start doing traffic filtering of this. We do it without a proxy, no kernel module. We use eBPF to grab traffic, sample it, and then match that against runtime threat feeds to identify recon and other types of traffic. Let's take a look at some of the alerts that have been generated from the traffic analysis and inspection. We're looking at inbound traffic to see what unusual activity have we seen. And there's a bunch of alerts. Some are clear attempts of exploitation, but a great many of these are reconnaissance. Let's take a look at the first alert, the oldest one. It's a recon. Look, we can see the bad guys have this particular CVE locked and loaded against this workload. There's a bunch of others, but this one's come up at the top. They're trying to do a reconnaissance event. You can see the packet payloads. You can see what we've been seeing in the wild, the JNDA LDAP infamous string that's a signature of the Log4j attack. This is HTTP, but it could be anything. We're broadly agnostic to protocols. So we could capture and interrogate gRPC or any other types of protocols as well. And we display how the whole activity, the alert as it unfolds, rolls over time using the Sankey diagram so that you can hunt in, apply policies and understand exploits as they're happening. Now, let's go and take a look at another alert, another event that we've detected. We could dive in, we could look at the payload in the inbound request. The bad guys certainly know what they're doing now. They've figured out what this is, what the exploit is, and they're starting to try and leverage it. You can see the offending string, you can capture the details. What are they trying to do? ThreatStryker categorizes, using the threat feeds, these different alerts. Here we can identify the intent. Is it attempted administrator privilege gain? Well, how can we do that? We can grab the base 64 data and we could decode it, put it through a particular filter, and you'll see what's going on. You'll see the HTTP LDAP attack as it's evolving. As we look further into the attack, there's so much more information that we can derive from capturing the network traffic from the attack sources and from attempts to laterally spread. In this demo, if we were to spend some more time, we could capture the tools that the attacker is trying to deploy in order to deploy Bitcoin miners and build a CNC network across our infrastructure. What we see as we use ThreatStryker and consider the task ahead of us is that many contemporary tools do not go far enough in order to understand how attackers are actively exploiting vulnerabilities in our applications now. The reconnaissance traffic that they're using to find vulnerabilities, the exploits that they're mounting, the lateral spread that they're affecting, and then ultimate exfiltration. You need something that goes far beyond just ingress traffic inspection. In fact, in this case, the most important data came from egress inspection. Network-based filtering, with its static sets of rules and signatures, can be easily evaded by obfuscating or wrapping data in various different types of encoding. And you need to be able to decode that and also correlate that with actual on-host events, files, processes, system calls, and the like. WAFs and API security tools are a good beginning, but they're limited typically to HTTP and only handle ingress traffic. Deepfence's ThreatStryker instruments the entire application, every single workload or node, north, south, and east-west traffic, decrypting traffic where necessary, and matching that traffic against various types of threat feeds in order to identify attacks as they unfold so that you can then step in and prevent them. Now that we know that attackers are running wild within our applications, how can we stop them from proceeding any further? With ThreatStryker, it's straightforward. As you saw, firstly, ThreatStryker correlates different types of attack behavior, understanding the intent and the class of the attack. Is it a recon? Is it exfiltration? Or is it something in between? An exploit, a remote command execution, privilege escalation. And we can step in and cut the pipe. When we see events of a particular type arising, ThreatStryker can talk to the local networking infrastructure and block that attack traffic, ingress or egress, to cut the attackers off at their knees. But just blocking an attack from proceeding is only solving half of the problem. ThreatStryker can also identify events on a host that may indicate that it's been compromised. Strange file system modifications, process activity, something that indicates that in some way that host, that workload has been tainted by attack behavior. And at this point, we employ our quarantine policies. We'll freeze, block, terminate, delete the host to your preference in order to prevent the tainted effects from spreading any further and to allow you to then perform forensic investigation to understand what may have happened. Putting all of this together, ThreatStryker gives you a complete solution for securing applications at runtime from a wide range of different types of attacks that seek to exploit vulnerabilities in the components that you have deployed. To get started with Deepfence technology, to identify where there are vulnerabilities in your production applications, check out Deepfence ThreatMapper. You'll find us on GitHub. Download, install, scan, and stay safe. And for the full level of protection, specific and unique to your application, ThreatStryker builds on the vulnerability map and information that ThreatMapper creates in order to identify attack behavior and block and neutralize attackers in their steps, preventing them from exploiting your applications.